Okay, let's look at these next pairs. It's pretty much the same thing, only it tells you to do something specific. It says determine whether the following pairs are equal by changing both to have the same denominator. Okay, so this is what I was talking about earlier. So it's saying change one of these bottoms so that both of them match. So we want both of our denominators to be in common. So this is kind of what I was talking about earlier. We're going to ask ourselves, what multiplies with 5 on the left to get negative 75 on the right? And I think you have to multiply by negative 15. I just did negative 75 divided by 5. Okay, well, if these two fractions are equal, then to get from this left to this right denominator, I should be able to multiply by negative 15 also. So let's see if this negative 15 that I already have here on this bottom left, if I multiply that by negative 15, let's see if I get 225. And I do. So that means, yes, those two fractions are equal. Let's try part B. Part B says negative 19 over 68 and negative 22 over 34. Okay, well, from 68 to 34, we don't multiply anything, but I think we could divide by something. We could divide by 2. That's how we get from 68 to 34. You divide by 2. So let's see. To get from negative 19 to negative 22, do we divide by 2? And the answer is no, we don't. So that means these two fractions from part B are not equal. Okay, let's look over here on the right. It says simplest form. That just means reduce. And we can use our divisibility rules that we've learned, or you can just go slow and try and reduce what you can. Okay, so let's look at this 156 and 153. They're not even, so I can't divide by 2. But if I look at the sum of the digits on top, 1 plus 5 plus 6, that makes 12. And if you look at the sum of the digits on the bottom, 1 plus 5 plus 3, that makes 9. And both of those are divisible by 3. 12 and 9. So since the addition of their digits are divisible by 3, the actual number is divisible by 3. So let's do it. We're going to divide by 3. This is called reducing. And we get 52 on top over 51 on bottom. And then I don't think you can reduce anymore. I think 51 is not cool. Yeah, I don't think you can reduce anymore. Okay, let's look at part B, 49 over 56. I think on those we can divide by 7s. So the top 49 divided by 7 is 7. The bottom divided by 7, I think that's a 8. Okay, this last sucker, negative 33 over 55. They're like repeated numbers, so that probably means we can divide by some 11s. So let's do that. The top divided by 11 is negative 3. The bottom divided by 11 is 5. So we just get negative 3 over 5. Okay, let's keep going. Let's go to this next sucker. It says, for each of the following fractions, choose an expression that equals or best describes the given fraction. Okay, so I think we already went over this. 0 divided by 0. That was at the very beginning of this packet. No, it wasn't. Where was that? Oh, it was on the last sucker, 5.2. 0 divided by 0 is undefined. So we got the answer for part A. A number over 0 is undefined. So part B is a number over 0. Part C, oh, part C is backwards. Look, the zero's on top. Let's see what happens there. When we have a 0 on top of a number, that just spits out 0. And then this last sucker, if we could cancel some of this, we could. Like on this part E, if it said maybe 22 plus 16a all over 24a. If it said something like this, maybe I could reduce all three of these numbers by 2. But if we look at all your numbers, you got a 2, 2, and a 1. And you can't divide all those numbers by anything. So I'm just going to say, nope. Cannot be reduced. Same thing over here on part D. If all this junk had 5s or something that I could divide by 5, then I could divide by 5. But this has a 5 and a pretend 1 and 1. So since I can't divide all three of those by something, I'm going to say, nope, there is no expression for the simplified version. Okay, let's keep going. This next one, it says find the simplest term for each of the following fractions. And we're actually going to do this factoring stuff from 5.2. Remember with the GCF and you pull it out in front? Okay. So, or there was that super awesome, where'd they go? Oh, here they are. Difference of squares, yeah. When we had difference of squares, it was really easy. Okay, so let's see here on part A. Oh, look at that, part A. Difference of squares right there on the top because A squared minus B squared. Both of them had squareds. There's a difference. That means minus, so yeah. So let's factor it. This top is a difference of squares. And I'm just going to put 2 parentheses with a plus and a minus. And then I'm going to say, okay, what squared gives you A squared? Them A's. What squared gives you B squared? Them B's. Okay, good. So the top's done. Now let's look at the bottom. If you look at the bottom, it's not a difference of squares because there's a plus sign. But maybe there's a GCF on the bottom. If I look at this 2A and 2B, what's in common? The number 2. So I'm going to put a 2 in front of a parentheses, and then I'm going to say, what multiplies with this 2 to get 2A? Well, A. What multiplies with this 2 to get the 2 plusative 2B on the bottom? Well, plusative 2. No, poop. Plusative B. That way, 2 times A is 2A. 2 times B is 2B. Okay, so I've just factored it. Now check it. Is there anything that looks exactly the same in the parentheses? Oh my gatos, look at this A plus B. Those are exactly the same. They cankle. Yes. Kind of like up here in the top right, when I could divide both the top and the bottom by 3, I did it, and I canceled them out. Same thing here. I can take off this A plus B from the top and bottom. So you're just left with A minus B over 2. This is for part A. Okay, let's look at part B. Part B, there's no pluses or minuses, so I think we can actually just do some crossing things out. Yeah. Okay, so for part B, since there's no pluses or minuses, I think we can just do common sense math. So let's do common sense math. 35 and 20. These are big fat numbers. What can you divide both of these big fat numbers by? Well, they have a 5 and a 0, so that means you can divide them by 5. So let's do that. If I divide them by 5, I get 35 divided by 5. 7. Okay, then 20 divided by 5. 4. Okay, good. Now let's look at the letters. This x squared on top means there's 2 x's on top. And how many x's are on bottom? Just 1, because it just says x. Okay, well, let's see. If I cancel out a pair of x's, how many do we have left on top? Just 1. So we put 1 x on top. Okay, now let's look at the y situation. For the y's, it looks like I have 1 y on top, but y to the 2 on bottom. So when I cancel out a pair of y's, one from the top and one from the bottom, they cancel, but I still have a y left in the bottom. So let me put that down there. And then check yourself. Can you reduce the 7 and 4 again? Nah, you can't. Can I cross out the x and the y? Nah, you cannot, because they're different letters. Okay, let's look at this last sucker. It's about solving for x and in a proportion. This kind of looks like what we did up here on the top left where we diagonally multiplied. We're going to use that same process of diagonal multiply or cross multiply or butterfly or whatever you call it. So this one says solve for x in the proportion. So we're going to diagonally multiply. So 3 times 19 is 57. And then it's equal to multiply that other diagonal. 5 times x is 5x. Okay, then finish it. What's this 5 doing to the x? It's multiplying. But we want that 5 multiply to go away so that I can get x by itself. So I'm going to divide by 5. I'm just dividing by regular 5. I accidentally put something else. Okay, so if I divide by regular 5, it might give me a pretty decimal. Let me see if it gives me a pretty decimal. 11.4, that stops. So that's cool. You can type that in your homework. If my answer would have been 11.444444444, then we would have to use the fraction for the homework. Okay, let's look at part B. First, we multiply diagonally. 4 times x. 4x. Other diagonal. 24 times 5. Negative 24 times 5, so negative 120. And then you say, okay, what is this 4 doing to the x? Well, it's multiplying, and the opposite of multiply is divide. So we get x equals negative 30. Yes. Okay, the next ones we're going to do are listing fractions smallest to biggest. Yeah, okay. Okay. So, to figure out which one is smallest or biggest, one thing we can do is change it all into decimals and then compare it that way. But when you have your own kids in class, they might not do it that way. So let me show you a different way. We'll do it both ways, but let me do it the way you might have to do it with your kids. Okay. If your kids don't know how to use decimals or dividing, one way we can do this is we can come up with some common denominators. And to get a common denominator, I need to multiply all of the denominators together. So my denominator is going to be made from 11 times 15 times 17. Okay, so what I'm going to do is I'm going to take each fraction and I'm going to change it to have a common denominator of 11 times 15 times 17. So first let me take this 8 over 11, then this 8 over 15, then this 8 over 17. And I'm going to multiply it by whatever I'm missing from my denominator. So if I want my new common denominator to be an 11, a 15, and a 17, this first denominator is missing the 15 and the 17 because it already has the 11. So I'm going to multiply by 15 times 17. Okay, this second fraction, if I'm looking at what I need in the common denominator, it looks like I already have the 15, but I'm missing the 11 and the 17. Okay, now let's look at this last one. It already has a 17, but it looks like I'm missing the first two suckers, 11 and 15. Now, these are going to be really, really big numbers, but the whole point of what we're doing is so that we can get the same denominator so that we can compare their tops, the size of their tops. Because right now, all these denominators are different. So all the slices of the pie are different. We need it to be all the same. So first, let's do this first fraction. 8 times 15 times 17 is 1275. Then on the bottom, we get 2805. And that should be the same denominator for all three of these. Okay, let me work on this middle fraction. The top, 8 times 11 and 17. 1496. Last one is 1320. Okay, so now that we all have the same bottoms, we can compare the size of their tops. So on the top, which one's the biggest? And it's this 14 sucker. The lowest is this 12 sucker. The middle is this 13 sucker. So if I want to write them in decreasing order, that means big to little, I'm going to put the big guy first. But where did this big guy come from? He came from 8 over 15. So 8 over 15 goes first. It's the biggest. Then the middle guy came from 8 over 17. He's the middle. And then the smallest guy is this 1275, and he came from 8 over 11. Yeah. Okay, woohoo. Let's go to this right-hand sucker. It says, for each of the following pair of fractions, replace the comma with the correct alligator or equal. Okay, well, we got 5 over 7 and 3 over 7. We're going to do the same thing that we just did over here on the left. We're going to come up with a common denominator so we can see which one is bigger. So 5 over 8, 3 over 7. And my common denominator should be whatever's already on the bottom, which should be an 8 and a 7. So let's see here. On this first fraction, I need an 8 and the 7 in the bottom, but I only have the 8. So I'm going to multiply by 7s. And that gives you 35 over 56. Let's look at this second fraction. There's already a 7 in the bottom, but I need my common denominator to have an 8 and a 7. So I'm going to multiply by 8, top and bottom. And I get 24 over 56. And then now you can see which one's bigger, 35. Which one's smaller, 24. So we're going to use their original fractions. So this 35 over 56 came from the original 5 over 8. This 24 over 56 came from the original 3 over 7. And which one's bigger? The 5 over 8. So the alligator is going to eat it because it's bigger. Okay. Okay, let's look at this bottom left. It says 10 light bulbs were in a chandelier. 2/5 of the bulbs were not shining. How many light bulbs were not shining? Okay, well, it says 2/5 were not shining. But this is saying 2 out of 5 were not shining. This chandelier had 10 bulbs in it. So how many out of 10? So we're looking for the question mark. So it's kind of like we're trying to come up with equal fractions. So let's think about this. To get from 5 to 10, you multiply by 2, right? So to get from 2 to the question mark, we're going to multiply by 2. And 2 times 2 is 4. So the question was, how many light bulbs are not shining? Not 2, because that's 2 out of 5. We had 10 total lights. So we changed up our fraction to see 4 out of 10. Okay, last sucker. It says, choose the best that's equal or simplified or something like that. So we kind of already did part A. Remember I told you if you had like 32 plus 16a all over 8a, and you could divide all 3 of these numbers by the same thing, you would. And you would be able to simplify. But if we look at part A, I have a 2, a 1, and a 2. You can't divide those by anything of the same number. So, nope. This does not have an equivalent, blah, blah, blah. Okay. Part B. We're going to use some factoring here. I think I'm going to do it over here because it's going to get crazy. Okay, part B is going to be like the ones from the previous page at the bottom left, where we tried to maybe use a difference to 2 squares or GCF so that we could cancel and make things smaller. So that's what we're going to do here. On this top, we can't quite cancel because there's plus signs everywhere, and there's all these different exponents. So what we're going to do is we're going to try and take the GCF. And let's remember, when we take the GCF and we're taking letters, we learned in the last unit that to find the GCD or the GCF of all variables or letters, remember to use the smallest exponent. Well, that's what we're going to do here too. If we look at this top, what's in common from the left of the plus and the right of the plus? And you should see that there's a common 2. Yep. 2 is in common. But what's the lowest exponent in common? 5 or 4? It's 4. Okay. So let's see here. What would I have to put on the inside so that when I multiply this 2 to the 4th in, I get 2 to the 5th plus 2 to the 4th? Well, to get to 2 to the 4th, since I'm already there, I'm just going to put a plus 1, because that way 2 to the 4th times 1 is 2 to the 4th, okay? Then, to get my 2 to the 5th, I'm going to remember that exponents add up. So I'm going to say 2 to the 1 times 2 to the 4th. You add those exponents to make 2 to the 5. Whoa. Okay, so let's do the bottom. First, we're going to come up with the GCF. And the GCF is definitely a 2 because it's in both sides. So for the top, my GCF was 2 to the 4 because that's the lowest exponent. For the bottom, my GCF is 2 to the 3 because that's the lowest exponent. Okay, so I'm going to put 2 to the 3, open parentheses. Let's see here. What do I have to put inside so that when I multiply with 2 to the 3, I get 2 to the 3? Well, definitely a 1. Bam. And then plus sign 2 to the something. And remember, that something has to add with my current exponents. So my exponent should add to this 6. Well, I have a 3 on the outside. 3 plus what will give me this 6? 3 plus 4? No, 3 plus 3. Okay. Now, we get to cancel some things. What? If you remember back to our exponent rules in 5.2 and several other places, if you have the same base on top of each other, you can subtract their exponents. Kind of like here. -2 to the 5 over -2 to the 1 equals -2 to subtract exponents. 5 minus 1. So that's what we're going to do here. We're dividing this 2 to the 4